And thank you so much for being here for another episode of Regarding Consciousness. I am Jennifer K. Hill, the CEO of OptiMatch and host of this show. It is a pleasure to bring to you today a very special guest who I have the privilege of knowing and getting to know over the last 3 years that I've been living in Lisbon, Dr. Miguel Ribeiro, who is not only an author of a wonderful book that we're going to be talking about today called Beyond Darwin. He is also an incredibly talented photographer who I believe just finished an exhibition in New York and is a traditional MD as well. Miguel, thanks so much for being here with us.
Thank you very much for hosting me, Jennifer.
It is my pleasure. Obrigada, as we say here in Portugal. So we are going to be talking today about Miguel's book. So Miguel and I first connected when I moved to Portugal about 3 years ago. And I happened to mention something around the idea of consciousness and the shows that I was doing with Deepak and Don at the time. And Miguel pulled aside and said, "Oh, Jennifer, I'd love to talk to you about a book I wrote called around the program hypothesis." So I was just really interested and fascinated, and Miguel graciously gave me a copy of the book, and I'm excited to share a few tidbits with you from it today. And Miguel, I thought it would be helpful to start off with maybe a little backstory of how you became inspired to write the book Beyond Darwin, and what is the program hypothesis?
How could I begin? I was much interested in photography, but in 2006, somehow I was going to queue for some subscription, and bought a National Geographic magazine. In it, there was an article by Carl Zema, which translated to Portuguese. This was a Portuguese edition. Translated to English would be something like the fin, the limb, and the wing. And there, I learned that the precursor species already had the genetic machinery for structures that they didn't have. So what this means with an example is that the fish precursor of land animals already had the genetic machineries for limbs and digits, although they had fins. And this struck me irreconcilable with the Darwinian evolution, with the randomness of Darwinian, because of the intrinsic anticipation in evolution. And I thought about it for a day or two, and then it just went off my mind. I was then busy with mainly photography and medicine. And then in 2008, so I have a good friend that was a well-known composer of contemporary music, and we decided to do some short films with music. And for that, I started sequencing photographs. So I had to scan hundreds. So I was developing black and white photographs, and started scanning hundreds and hundreds, actually over 1,000 negatives. And during that, I was used not to ever see television, started seeing films of National Geographic, Discovery, and that kind of thing, and became interested in science, started reading books. And that was in about 2008. In 2010, I was reading a book by Paul Davies, with the Goldilocks Enigma, and in it, he was dismissing one after the other the various possibilities of a universe by chance. And suddenly it just occurred to me that if we replace randomness with a program, everything would be instantly solved. And so I was quite excited with the idea, revived the National Geographic magazine article of Carl Zema, and started writing on the idea that the mutation was programmed rather than random. And why why biology for a random universe? Because if a universe hosts life, the most complex thing known, that appeared by accident and evolves by a random mutation, by DNA copying errors, then that universe has to be random. And so that's the beginning of the story. The initial idea was, in fact, that in the human genome, only 2% are genes, and genes are dedicated to the synthesis of proteins. So the big bulk of the human genome is what they call junk DNA. And junk DNA had to be junk for evolutionists because it doesn't obey natural selection. It's independent of natural selection. So we have an enormous amount of DNA that is independent of the natural selection. If that DNA evolves in a coherent manner, then that surely would challenge the Darwinian principle and of purposelessness and randomness. And so I started exploring the idea, went on to search for that possibility of people that thought that junk DNA could host the program in the genome, because there must be a program to control the activity of genes. And then suddenly I realized with great disturbance, personal dissent, because I was a Darwinian until then and atheist all my life, not all my life, but since late adolescence, that a program is implicit in a program. And so this would be a creationist explanation. And we all know that although believers are 100% creationist, the term creationist has a terrible connotation and is really bad news. And so that disturbed me for almost a month, almost physically. And then I decided from then on that I was going just simply to try to go over any preconceptions and try to make the case of a theory just based on facts, on data gathered by scientists, irrespective of interpretation, because that's where I essentially differ from conventional science, well, conventional, what we say, mainstream interpretation. So basically, I would say that's that.
You know, I found it fascinating, Miguel. When I was reading the book, I didn't realize this. Correct me if I'm wrong, but I think you said something in there that one of the many reasons that Darwinian evolution by natural selection is an impossibility, which is something that Deepak and Don and I have also spoken about in our episodes, is that it violates the second law of thermodynamics. Am I remembering that correctly about things getting, you can't go from uncertainty to certainty, correct? Something along those lines?
Yes, in fact, the problem of mainstream science, mainstream thinking, is that we start with a random universe. So the initial soup of particles, according to Ossenfelder, is just that. It's a structureless plasma of particles. And Penrose calls it a system internal equilibrium, which is the maximum of disorganization. And yet, so to go from there into a complex thing is impossible, theoretically, because of the second law of thermodynamics that dictates the opposite direction of things. And so they claim that gravity is the ingredient that can make the difference, which that would take too long now here as an explanation, but you can find why it's a fix rather than a sound principle. And but the central idea of the book is actually that randomness cannot generate complexity, and so we live in a complex universe, unquestionably. So it's made up of layers of structures, all interconnected by codes, protocols, hierarchies of feedback regulations. Also, like programmed constructions, it's modular, and it has integrated outcomes, and it evolves in a meaningful way. So random systems, totally random systems, only have random outcomes, and so which is something totally different from what we have. So it doesn't, nothing fits in with it, except I could possibly say that, and I think that's one of the problems of Darwinism, is that I think most modern science has borne out of the contestation of the religious explanation. So in fact, the Earth doesn't have 600,000 years. It's not the center of the universe. The astral bodies are not magically or by miracle in equilibrium in the firmament, but they obey universal laws of physics. And then Darwin came with a theory that is plausible and that dispenses the way the presence of a God. So it tells us that we descend from bacteria and we're not created on the image of God. So with these premises, we eventually, they say religion is wrong. Any obstacles that come to this explanation, this scientific explanation, will eventually be solved. And this has basically been the position of science. On the other hand, we have to remember there were only two players on the table: the religious explanation and Darwinism, or the Darwinian way of thinking that extended to all of science. And so this brings us to the next player on the table, which is the program hypothesis, because now we can mention a few, but Darwinism is just plagued with contradictions. So it's no longer just purposeless and randomness, because most, well, even life from the beginnings is instilled with purposefulness.
Yeah, I find this so fascinating. One of the other things that I wanted to highlight in the book is you gave reference in the book to a couple of different types of coincidences that couldn't be explained by Darwinian evolution. Do you want to talk maybe about that and how that ties in as well to dark matter and the multiverse?
Mm-hmm. Well, so one of the usual explanations for the laws of the cosmic coincidences, so the exact recipe of laws of physics and parameters, is the multiverse. So there are infinite universes. So you can get all sorts of substrates. The substrate of this universe are particles and radiation, and then for this would enable this theory all sorts of laws of physics and constants of nature that could then explain just this coincidence of ours happening. Maybe I can tell you the problems of that in just by telling you my view. So in this view, and then we'll go backwards to that. So in this view, the universe is information and energy. And information is what I call the program of the universe. You can call it consciousness or whatever. And this program prompts energy to yield the 17 fundamental particles. In other words, due to the equivalence of energy and mass, or matter, you get this exact recipe of particles, which include the electron, the quarks, the various types of quarks, the gluons that bind quarks into nucleons and nucleons into nuclei, the Higgs boson that gives particles mass, the photon, etc., etc. And then, armed with the laws of physics, a possible algorithmic structure, this program, following a predefined blueprint, writes the story of the universe. So if we don't accept a program, the implication is that we have to have these incredible coincidences, meaning by chance to have all these exact particles and to have these precise laws, etc. Another obstacle is that this multiverse assumption for the origin of the diverse laws implies that laws are objects with their autonomous existence, and that can be, which is nonsense, because laws are specifically designed to control the interaction and actions of the agents in a system. So they made specifically for systems. They don't exist by themselves. Also, laws lack causal power, meaning even if you have all the right ingredients, so you have exact particles, the precise laws, all the parameters, the mathematical equations that also enter the scheme, even then you need an inciting agent. You need a program to put everything in action. For example, you don't expect the rules of chess to spark off a game, or the grammar to write a text, those are or the laws of movement to induce movement. So you have to have a program or an outside agent to do the thing. So it's basically that's the situation. Yes. So no, you can't explain the universe otherwise. So it's not only the exact components, all the exact ingredients, but you need an inciting agent for it.
Yeah, you gave a great example in the book too of like traffic laws. You said traffic laws, it's not like physics laws and traffic laws are similar. I just thought that was so interesting.
Yes.
It sounds like we've just kind of convoluted science at the time that when that Darwinian evolution by natural selection emerged, it was because of the fact that you had, to your point, religion, and then you had, oh, not religion, Darwinian evolution. And yet we've learned so much. And it's, from what I understand from a lot of my scientist friends, is it's not just Darwinian evolution by natural selection that's defunct. It's that even things like Einstein's theory of relativity, Newtonian physics are coming into question because you can't measure things below the Planck scale. And so that's why I think whole new ways of thinking, which may be explained by your program theory, have to be considered in order to explain how these coincidences or these occurrences are happening in the universe.
Well, the program idea is just overall, it's overarching. And the idea that behind this is that the world starts quantum, and the macroscopic world, the world of the physical world, is an emergent from the quantum world. So we can do a trace analogy with a computer. And so what we have is a quantum world that doesn't define an arrow of time. Everything can be done and undone, has some peculiar properties. And then through quantum wave collapse, the coherence, it goes into the macro world of that is the world where we move. And this world has entirely different properties. So it abides by the causality rule. It defines an arrow of time. It's a deterministic. Action and reaction are repeatably reproducible given the similar circumstances. And so there are two different realms. And this is why you can't join quantum and gravity. And so it's just like that. And that's why the pursuit of a quantum gravity is a failed thing. It's and so these are just I have a similar analogy, which is with a computer. So with a computer you have a flow of electrons. So if we just reduce to the bare minimum the workings of a computer, you have electricity coming into hardware and software. That's essentially a flow of electrons, which is completely random, and the program converts that into electric signals, in patterns of electric signals, significant, and then those electric signals are converted by the other arm of the program into some display on the monitor, for example. With possibly the nearest analogy is with a computer game. Likewise, with the universe, you start with with a random quantum realm, and this program converts it into significant patterns. So the patterns of atoms that are the basis of our reality, and which the brain of animals, the second arm of the program in the computer analogy, transforms into the intelligible realm that is our reality. So this tangible thing that we can understand, because atoms are mostly empty space. So an atom, the nucleus of an atom, if an atom is the size of a football stadium, is like a nut in the center of the field, and the electron is a pinhead orbiting in the last row of seats.
Wow.
So an atom is also barely detectable in an immense void, and so this unintelligible construction is actually the real substrate of our universe. So what we see and hear and feel is just is a construction of our brain. It doesn't really exist, and so for this construction made simply of atoms to have consistency, to be meaningful, and to evolve in a meaningful way, it has to be programmed, and also it's converted into another meaningful thing, which is the world of perception. So
I can
program is incontrovertible in that sense.
I appreciate all this, though I can hear the question in our listeners' and viewers' minds. The question on everybody's mind is, what about death? If there is just one big program running all of this, I know you touch on this in the book, in the idea that I believe it's atoms in the universe, they don't change when you die, that they still exist. Can you explain for people out there who might be grappling with, well, what does that mean if we as a human being die, if this is just a computer program?
So take, for example, water. So you have, it's made up of two components, oxygen and hydrogen. They are inflammable gases, and at room temperature. Water is a liquid, and it's anti-combustible. What this means is that you get two entirely different two chemicals, and you get by emergence something else, something new, with entirely new properties. Now, what is life from this point of view is the emergent feature from the independent evolution of nucleic acids and nucleotide chains and cytoplasm. And then you get something from this merging that is entirely new properties. So this is life. What is the life-defining feature? It's not reproduction, metabolism, the control, management of energy. It's the sentient program. So what comes out from this merger is this central control that is capable of maintaining metabolism, and I call it sentient program because it can sense the interior of the cell and maintain its composition, that is homeostasis, within the extremely narrow limits compatible with life. And it senses the outside, the environment, and can take adaptive action, and is able to detect nutrients, flight from noxious environments, find mates, etc. So essentially, this change from inert chemistry to life, it can be, you can possibly grasp the magnitude of the jump by thinking that inert chemistry means a structure that is in the power of the physical and chemical influences of the environment, and a living creature is one that has causal power, meaning it is capable of controlling taking advantage and moving and changing the environment to its own advantage. So this is from the onset of life. So as opposed to Fukuyama, who thinks that human action is the only thing with purpose in the universe, actually life is instilled with survival instinct and this purposeful action right from the outset. And then so it's basically that. We can go then on. So this is the core of every living creature, and so eventually, perhaps with the Cambrian explosion, so with the Cambrian and the evolution of sense organs and neural networks, a new form of emergence appeared, and consciousness was born from there. And finally, humans developed self-consciousness. But so these probably are the great markers on the evolution, according to this idea. Now, you mentioned death. So when a cell, so cells in the tissues, they are in cooperation, and sometimes cells have to die, and they receive orders from the environment for something called apoptosis. And what they do is that they open pores, and they lose their electrical potential, and they rapidly die. So it's like life is dependent on the maintenance, so unstoppable maintenance of electrical potentials. So, and for that, it requires all the metabolism. So a person, a living creature has a certain chemical composition, and but with death is exactly the same composition. And the idea is not that the soul left its organism, but simply his metabolism, its metabolic machinery was now incapable of sustaining these electrical potentials across membranes, and life just disappears instantly.
Fascinating. Well, I guess the final question I have for you today, Miguel, is there free will? If this is all programmed, what's to stop us all? Why even have free will if everything is already pre-programmed?
Well, obviously, the idea here is that's a predefined story that is following the blueprint is already laid out, and so it's a deterministic universe, and probably no free will. And in fact, Ben Libet in the 80s showed that there's no free will in the strict sense of the word. So, meaning, if you have self-awareness has no executive function. So it serves as observers and commentators of ourselves and the environment, but is not. It has no executive thing, and this was confirmed by Christoph Koch very few years ago with functional magnetic resonance. And imagine that you have a subject being tested, and the person at doing the the functional magnetic resonance, can know if the person being tested is going to press the green or red button before the person being tested knows what he's going to do, because there is an action from the non-conscious area of the brain that takes the decision. Then that impulse reaches conscious areas of the brain, and then the motor cortex that determines that. And so you can trace that this action from non-conscious actions of the non-conscious portion of the brain takes a little lag of time, and but the observer from the fMRI can say, well, is going to do that now, and it will be this movement. And so before, and the person only has consciousness of what's going to happen when the impulse reaches the conscious area of the brain. And what happens is we get an illusion of agency when this impulse reaches, because we think that this is when we decide to do something, and that the decision is within is our decision. Now, this is in the strict sense. Obviously, there's no free will in that sense. But why is there personal responsibility? Because the impulse came from the same self, from a different layer of the individual, but it's the same individual, so he's responsible. I don't know if I was clear in the subtlety,
Yeah,
but
I think I understand what I'm hearing you say, Miguel, just to repeat this back, is on a biological standpoint, technically there's not free will according to the program hypothesis. However, at a agent, if you want to call it that standpoint, the individual level, it does resonate, or it does come from, emerge from the individual that is then provoking the action. Is that correct?
Yes. So, but imagine that you have a bee colony, and that bee colony has a certain, so you're a programmer, and that bee colony is going to evolve in this way. And if after so many thousands of generations, evolve into some other insect, etc. So everything stipulated. Is that on an individual level so strict as it appears? Probably not, because this is likely an algorithm-based program where which the averages are the important thing. So many bees can be killed, and others are blown out by the wind, etc. But the program, so these little sideways, the importance is that these converge into the avenues of the program, and eventually things. So there may be so we don't know, but it's not impossible that everything is stipulated like in any PC program, but it's likely that there is some freedom. It's not maybe freedom of choice, yeah, perhaps, and that, but the average of large numbers bring everything into the fulfillment of what was pre-planned.
Wow. Thank you so much, Miguel. It's been a very insightful and stimulating conversation. And I invite us all, it's always interesting to reflect on our beliefs, reflect on what we think we know, just like we thought we knew for millennia that evolution by natural selection, or that this or that was legitimate. And yet science is always making these new leaps and bounds, and we are discovering new things all the time. And that's the beauty, in my opinion, of consciousness, is getting to choose what we put our energy, what our attention goes into. Whether it's a free will choice or not is TBD, according to Miguel Ribeiro, who's been here with us today. So Miguel, any closing thoughts from you before we wrap today?
No, perhaps, one interesting thing, but probably would take too long to explain, was why mutation is not random. Can I have a minute just for that? Although I'm not sure if it will be sufficient. But for example, Darwinian evolution is thought to be gradual, and due to point mutation, which is a random phenomenon. Contrary to that, most mutations happen as a secondary feature after epigenetic modification. So what happens is there is initial epigenetic modification with 100% Lamarckian, and then after 2 or 3 generations, that it seems beneficial and appropriate for the environment in terms of adaptation, and mutation comes later. So not only mutation is not the primary factor, but mutation falls in hotspots, not in the entire, by a chance in the entire genome. In the specific hotspot, with something that ranges from 1 nucleotides to a bit over 100. So it's a tiny, minute speck of the genome. And in addition, Darwinian mutation, this kind of mutation, is also just for fine tuning. That's not the major thing. In addition, there is adaptive mutation described by John Keynes in the 80s, over 30 years ago, still debated by some evolutionists. It's absolutely empirically demonstrated, and it's not that it's just incompatible with random mutation. They are mutually exclusive. It doesn't make sense to have random mutation and adaptive mutation. Then the other kind of mutation is through transposition. It was described in the 40s, late 40s by McClintock, and totally repressed by Darwinism, because they wanted to remove all intentionality from the biology, and she earned later a Nobel Prize in 30 years later in the 80s. Now, this is visually interesting to this kind of mutation, transposition, is equivalent to cut off a little page from a 1,000,000-page book, because remember the number of characters in the genome is the human genome is 30 billion, and put it at random in another page and get an improvement not only a meaningful passage, but an improvement in the entire book. That's what the impact of transposition has in biology. And after that, there's also the meaningful junk DNA. Then came the algorithms. So Leslie Valiant came up with the idea that the organism is a computer and run by algorithms. Consciousness is another, etc. So we could go on forever here, but so all the time, whenever one asks a biologist, so how the evolution goes, random mutation, natural selection. Natural selection, on the other hand, it selects for traits, which implies in computation, and doesn't select traits and not proteins. And traits imply computation. So actually, natural selection supports the saltational views of the program hypothesis, where the evolution that is important is of traits. I want at the moment oh yes, I'm now listening to you.
Yeah, that is pretty incredible. I just realized I was on mute. I was saying that we're all going to have to go back and re-listen to this, because what you just said was so powerful. And I do remember reading about that in the book, that analogy of having this 1,000,000-page book and then just randomly tearing a piece out and putting it back in, and how that is the equivalent of Darwinian's evolution by natural selection. I think that there's always so much more for us to learn out here, Miguel. And I just deeply appreciate you sharing your wisdom with us today.
Many thanks, Jennifer.
Yes, thank you, my friend. And I believe the best place for people to go to find out about you and your photography, as well as the book, is miguelribeiro.com, correct? Or let me see here. It's Miguel Ribeiro.
It's miguelribeiro.net.
.net. Sorry about that. miguelribeiro.net. Yes, so we'll be sure to go ahead and include that in the notes. And we deeply appreciate you for joining us today.
Thank you very much.
Yes, thank you so much. And intending that everybody out there maybe learned something new or thought of something new. I know I learned a lot of new things when I read Miguel's book, and I'm so grateful that you joined us today, my friend. Thank you for being here.